All right. Last class, according I started. Last class, we started talking about the last class we talked. I did a revision on constraints. We looked at constraints generally and how to work with them, and also other table statements, how to alter tables and alter objects on the database, right? I gave us an assignment last class. We started with an assignment. I said add 3 more attributes to the driver's license entities created earlier. Drop 2 attributes. Drop 2 attributes from the list of attributes created on the driver's license entities and rename the primary key column and extend the length of the first name column to 70, right? I think I only got one person's result or submission, right? So I'm not going to take offense on that because class is still on for the week. So please submit your assignment, right? So we looked at check constraint last class, right? And we said check constraint is a constraint that we use to set a condition or a policy or a rule on a column, right? Such that the values in that column, the values to be inserted in that column must meet that condition for them to be inserted, right? They must meet the value, they must meet that condition for them to be inserted, the values that you want to insert into that column. So take, for example, look at this, right? This is a business case that we have here, right? Right, it says ensures that every staff, so the business case is ensure that every staff earn at least $1,000, right? Ensure that every staff earn at least $1,000, right? So using the check constraint in an alter table statement, we're able to alter the table staff, right? The table staff, alter table staff, modify salary to integer and unsigned, that's the data type. And look at the check constraint that we had, a check salary is greater than or equals to 1,000. What that means is that when we try to insert into this table, if the value that you want to insert is less than $1,000, it would not allow it to enter, right? We'll see all of this when we start inserting. Today we'll start DML statements, so you'll see how to insert into tables and all that, right? So you will see that if the value you are inserting into the salary column does not meet this condition, right, then that value will not be what? That transaction will not be done, right? Will not be done. So we looked at that. We also looked at how to create a constraint, how to create this same check constraints in the create table statement. Create table statement. How to use the check constraints, using the check constraints in a create table statement, right? How do we do that? So we tried to edit the driver's license of one of us yesterday. This submission is from one of us. And I tried to add check constraint. I added check constraint on the age. Let me remove this. Right, that's what's causing the error in that. Right. So we added check constraint on integer unsigned, right? Not null is the first constraint there. And we added a check constraint. Check that age is greater than what? 18. For you to get a driver's license in Nigeria, you must be at least 18 and above, right? So we say check that the age is what? The age is 18, right? Look at height, right? Check that what? Check also, we put a check constraint on that. Check that height is what? Is greater than 0. Can you see? Check that height is greater than 0. Check that phone number. Check that the length of the phone number is equals to what? Is equals to 11. Check that the length of the phone number is equals to 11, right? So this is how to work with constraints, right? With the check constraint. And I also talked about the foreign key last class. I said the foreign key is a constraint that allows us to reference a primary key column from a parent table on a child table, right? You reference a key column, a primary key column from a parent table to a child table, meaning that you have a column that is a primary key in a particular table, and that column is in another table, is referenced in another table, such that the table where it is referenced, it serves as a pointer to the code to the table where it is coming from. Serves as a pointer to the table where it is coming from. So basically, that's what we did yesterday. And we could not do too much yesterday because of the network, which I apologize for, right? So we also looked at how to rearrange columns, right? How to rearranging the column position in a table using the after and first clause, right? So we look at it, we altered the citizen table and we made the phone number column come after the gender column. And here we modified the local government and made it first. 1 minute, please. 1 minute, please. 1 minute. All right. So we looked at how to rearrange columns, right? Modify and making the phone number come after using the after clause, come after the gender column. And here we modified the citizen table and made the local government column come first, right? And here we returned NIN as the first column, right? And yesterday also, I also showed us how to add more columns or use the other table to either add more columns, drop multiple columns, delete multiple columns, modify multiple columns at the same time instead of doing them one after the other. So look at this here. We created a table called T, and we have column C1 as integer, C2 as character. And what did we do? We altered the table T, and we added multiple columns at the same time in one single alter table statement. We added multiple columns at the same time. Then we modified using the same alter table statement. We modified multiple columns at the same time. And we renamed multiple columns at the same time as well. The columns C1, C2, and C5 we renamed to scores, epoch, and queen. And we dropped those columns, multiple columns at the same time. Right? So then we renamed the table itself from T to tails. Right? We renamed the table from T to tails. So basically, that is what we did yesterday. And today, let me see. Still have more people who have not joined. Okay. Please let them know that class have started so that we can continue. All right. So today we're moving to a very interesting part of SQL and a very short one at that. Okay. I said we wanted to talk about indexes before we go into that. I don't know why I'm very eager, right? So let me show us what indexes mean. Let's talk about indexes before we go into, yes, indexes, right? What are indexes and how do we create them, right? What are indexes? So we'll talk about creating a view later because we need the select statement to be able to create a view, right? But let's talk about index. Let's talk about index, right? Indexes are used to improve the performance of query by quickly finding rows with specific column values, right? Basically, when we talk about indexes or index, right, we talk about the fact that index are objects on the table that helps us improve query performance. Index are objects on the table that helps us improve query performance, right? Basically, what that means is that an index is a marker or is an object that quickly helps us find rows with a specific value, right? Let me give you an example. we are 213,000 people in this country, 213 million people in Nigeria, right? If we have somebody if they're trying to look for somebody's NIN, right? Say your NIN is 101325377, whatever it is, right? And the question is, how long will it take the system to process finding just one NIN? How long will it cost the system? And the rule of thumb, right? The Oracle rule of thumb is that when your query is going to, I hope you're listening to me, when your query is going to retrieve less than 1/3 of the table, when your query is going to retrieve less than 1/3 of the table, then you need to put an index on that table. What that means is that if you send a query to the database and the query is going to retrieve less than 1%, right? So less than 1/3 of the table, right? What is 1/3 of 213? 213 divided by 30, right? That would be about 60-something million, right? If you'll be retrieving 60-something million rows from the table, then you need to what? You need to add an index on it. Less than what? Less than that, you need to add an index on the table. Are you following me? So indexes are very, very important. Let me break it down to you in a more simple term, right? If you have people wearing white, you have 100 people in a hall, all of them wearing white, right? And there's one person wearing black. Will it be easy? And you want to pick out the person wearing black. Will it be easy for you to pick out the person wearing black? True or false? It will be easy picking out the person wearing black. True or false?
True.
Hello, true or false? Huh?
True.
True, right? True. Because why? The person is distinct from the people wearing black. Wearing white. But if you want to pick out somebody wearing white from the mass of people wearing white, would that be easy? Response, people. Response.
No, sir. No, sir.
No.
Exactly. And that is what index is all about. That is what index is all about. Index basically is that helps is that object on the database or in a table in your schema that stands out every single object, right? It makes every single object stand out such that when I'm looking for a particular value, the value is distinct from every other value. Hence, I'm able to get that value fast. It says without an index, right? My SQL must scan the whole table to locate the relevant rows, right? But because in the database we have let me use the large old example that I was using. You have 100 people, and out of those 100 people, each you have somebody wearing orange, you have somebody wearing green, you have somebody wearing red, you have somebody wearing black, right? If you are going to fish out these people from that crowd of people wearing white, it will be easy because why? They are indexed. Are you following me? It will be easy because what? They are indexed. They are indexed already. They have an index on them. Following me? They have an index on them, right? So if you go to university, right? You are trying to look. You see a crowd of students, right? And you want to identify who is a law student, right? It is not hard. All you just need to do is look for this on a regular day. Any student that is wearing white and black, because why? They have a uniform that stands them out or that makes them stand out. That's an index. You look at people who wear green, who wear green overall. In my school, you don't need to ask any question. You just assume that that person is from the agricultural department, because why? They have that index that helps them stand out. Are you following me? And that's the essence of index, such that you don't have to ask the whole school, I'm looking for an agricultural student. By just seeing them, you understand who they are. If you see a medical doctor, by dressing, you know this person is a medical doctor. But if you see a data analyst, right, by dressing, you won't know he's a data analyst because we don't have an index. We don't have indexes on us. Are you following me? If you see a science student, right, you see them in white lab coats, right, you will know that this person is a scientist, right? And that's the essence of index. So the larger the table, the slower the search. So when you are trying to get data from an unindexed table, right, it takes a whole lot of time. Let me give you a proper example again. If you go to a library, remember in the first class, I was talking to you about, when I was talking about index, I was talking to you about index, and I said that imagine you are in a library and the library is not indexed, right? What we call index in the library is that when you enter a library, say a university library, right? The books in the library are arranged by faculty, and in each faculty there's an hierarchy, right? The books in each department are arranged by faculty. So faculty of medicine and basic medical science, faculty of agriculture, faculty of social sciences, faculty of this and that, right? So the books are, so you know that if you are looking for a book and you're in agricultural department, or you're in computer science department, or the computer science department, yeah, you won't go to medicine department to go and look for your book. You won't go to basic medical science or health science faculty to go and look for your book, because you know that your book is not there. Are you following me? Right? So you go into the library, right? The books are arranged faculty by faculty, and in each of those faculties you have what? The books arranged by department. So you have an hierarchy, right? You have an hierarchy that says that, let me see if I can draw something out here, right? So you have an hierarchy, right, that says, I hope you can see my screen, right? You have an hierarchy. So this is your library, right? Now inside the library, the books are arranged by what? By faculty, right? So we say faculty A, faculty B, hold on. Faculty A, faculty B, faculty C, and faculty D, right? Then inside faculty A, you now have faculty A1, right? That means department, you have department A1, A1, A2, A3, A4, right? Then you have in department B, you have what? You have B1 and B2, right? One minute, please. Let me put on the generator. Apologies, I'm back. Right? So we're talking about indexes. So we say index department C1 and C2. Right? Then we have department D1 D1, and let's say department D2. Right? So what does that mean? Right? Each of these departments can now be broken down into their literatures, right? Different literatures, different literatures, different literatures, right? From each of the departments, right? From each of the departments, different literatures, right? So what you see is that if I'm looking for a book on data analysis, let's say data analysis, right? This is the book I'm looking for, right? Do I have to go to department B or C or D? I need response, right? Do I need to go to department B, C, or D? Viola, what's happening to your network? Right? Do I have to go to department B, C, or D? Hello?
If you are looking for what?
If I'm looking for, look at it. I have a book. Hold on, let me change the color of my book here. Right? So I'm looking for this book. I'm looking for this book that I circled. It's a book on data analysis. Remember, we're in a library, right? I'm looking for this book, and this book is in department A, right? Under department is in faculty A. Under faculty A is in department A2, right? And under A2 is on this side of the book, right? Of the library, right? Do I need to go to department B or faculty B or faculty C or faculty D?
You need to go to faculty A.
Exactly. So I have to stay at what? I have to stick to A. Now, under A, do I need to go to A1 or
No.
A3? Exactly. Or A4, right? So what it means is that I go to A2, right? I go to A2, and under A2, right, I'm able to what? To locate it. What have I done? I go to the library, look at the pathway to it, right? This is the pathway to the book. Can you see? That's the pathway to the book. Instead of having to what? What do you say?
I said, and that was indexing.
That is indexing, right? Because why? And what does that mean? It means that I don't have to spend 10 hours searching for the book. In 5 minutes, I'm able to get the book. Because why? There is an index already. But imagine that there is no index. Hey, you are going to spend hours looking for the book, right? And that is this basically is the essence of indexing. So when you have database, right, we add indexing to values on the table, just so that they can improve query retrieval. They can improve the performance of queries, right? You can improve the performance of query, right? So take for example, you have in your freezer, right? You told your son to go and get you a bottle of water, right? But inside the freezer, you are saying that there's a particular bottle of water that has lemon on it, right? That has what do you people call that thing, right? That is it has lemon flavor also, right? But it is not written on any of the bottled water. In fact, none of the bottled water has labels, right? They're just plain bottled waters, transparent bottled water with no label. What happens to the child? It's going to be confused. He doesn't know which one is what has lemon flavor. But if you put lemon flavor on the label of the one that has lemon flavor, what happens? The retrieval of that bottle for you is faster. And basically, that's the essence of indexing. That's basically the essence of indexing, right? So index makes query retrieval fast, right? It says an index is a data structure such as we have what we call the B-tree index. What I just drew for you is the B-tree index, right? The B-tree index that improves the speed of data retrieval on a table at the cost of additional write and storage to maintain it. Now, is it the job? Now, this, like I said, I used to go overboard in my curriculums, right? The question will be that, is it the job of analysts to create indexing? No, right? Because you're not the one managing the database. So it's the job of a database administrator. So I'm just trying to let you understand what goes on. That's why I'm going through all of this, right? Right? It says that The query optimizer may use indexing to quickly locate data without having to scan every row in a table for a given value. So instead of having to scan every row when you run a query against the database, right? The query optimizer just goes exactly to the data that you need, because why? They have index on them, right? Because they have index on them. So indexing, when you create a table with a primary key, now this is where it is very important that you know, this is what I just want you to understand. When you create a primary key constraint, right, an index is created. When you create a unique key constraint, what happens? On a column, an index is what? Is created on those tables. Let's go back to my SQL. Let me show you, right? Let's go to where we created primary keys and foreign keys and unique keys, right? Oh, awesome, right? Look at it. On the DID column, you can see primary key. Anytime a primary key constraint is added to a table, right? A primary key index, a primary index is added, right? Let's talk about index now. Let me just put this here. Index. Right? Their primary key, their database object that helps improve query performance, right? So index are created implicitly when you create either a primary key constraint or a unique key constraint. So when you create a primary key constraint, what happens? Let me just put it this way. So you understand. When you create a primary key constraint, a primary key index, I'll just put it, primary index is created, right? When you create a unique key constraint, a unique index is created. It's as simple as that, right? So those are implicitly way. When you say implicit way, when you say implicit, it means that the system is creating it for you. The database is creating it for you. Data server is creating the index for you, right? So when you are retrieving data from a primary key column, what happens? Or a primary key column here, right? You are using the primary key index, right? Look at it here. Let's go back to this. Please let me know if you understand what I'm saying, right? Look at it, DID, that's driver's license ID, right? Primary key. So what it means is that on this table, on this column, every value on it is distinct. Every value on it is unique. So it will be easy to use this column, to use this value to search out values on the database. If I'm using the surname to search out values, it's going to take longer time unless I use the DID, right? So when I create a primary key index, a primary index is created. All right, look at it here. We also have a unique key index on phone number. Every phone number has to be unique, right? When you create a unique constraint like this, what happens? A unique index is also created, right? A unique index is also created. I don't want to overemphasize that. I don't want to spend so much time on that, right? So just know that when you create a primary key constraint, primary key index, a primary index is created. When you create a unique key constraint, a unique index is created as well, right? So you can also create indexes by yourself, right? It says MySQL automatically creates a special index called primary key, right? Which this includes what? This index is called a clustered index, right? Which means that it comes with the constraint. It's clustered with the constraint, right? A primary index is special because the index itself is stored together with the data in the same table, right? And the clustered index enforces the order of rows in the table, right? Let's look at how to create constraints so that we can move on to more interesting stuff, right? This majorly might not be, you might not create an index on database because the database does not belong to you, right? Except the database belongs to you, right? Usually it is the job of database administrators to index the table, right? Or server administrators and all of that. But it's also good that you understand it if you find yourself in an environment where you have to be the one to create your database and maintain your database, right? So that's why I'm going through all of this. Awesome. Right? So how do you create index? Creating index is very simple, right? You create the index. Look at the example. Create index, the name of the index on what table and on what column, right? Look at it, right? I'm creating an index here. Create index. Create index. This is the name of the index. And I'm creating it on what table? The department table. And on what column of the department table? The department ID, right? You can create a table, right, and add an index into it at the same time. So look at it. I'm creating a table here, creating table T, C1 integer primary key, C2 blah blah blah, C blah blah blah. Look at it, right? And what happens? I'm creating an index for what? I'm creating index on C2 and C3. Remember, primary key C1 comes with its own unique index. I mean, with its own primary index because I created a primary key there already. But I want to also index what? C2 and C3. So I'm using the index function here to what? To index what? To create an index on C2 and C3. Right? Let's look at an example, right? Before we go on. I don't want to waste, this is not really I just wanted to show us that, right? Let's describe what database are we using now. Use Nigeria. Please let me know if I'm speaking too much English. If you don't understand, please let me know, right? Awesome. So we have tails. So this describe tails. Let's see from our table yesterday. Tails, awesome. So we have C3, we have C4, we have C5, we have C4, C7, and C6 and C7. So I can create index, right? I can create index like we did here. So I can say create index, right? And I'll give the index a name. I can say tails underscore, the tails is the table, underscore index, right? IDX, right? I can say on tails table, look at it, on tails table, what column of the tails table? I want to create it on C3. Create it on C3. If I run that, the index is created. Can you see? Right? If we describe tails table again, can you see? It's telling me that I have an index on it. Can you see? If I edit that, let me show you again. If I edit this, create index copy. Let's create on C6 and C7. Right? Let me run this. Let me call this index 2. Right? So if we describe the table again, tails, what do you see? Can you see? We've created a mutual on that. Why is it not adding to C7? Tails. Are you following me? Show index from tails. I want to see all the index on that table. Look at it. index. Look at it. Can you see? The first one we created is index, this one. Can you see? Tails underscore IDX. Can you see? Key name, that's index. On what column? C3, right? Cardinality is 0, coalition is 0, all of those. What kind of index is it? It's a B3 index. Can you see? What kind of index is the B3 index? Right? Look at this second one that I created here. The second one I created here is create index tails underscore IDX 2 on tails C6 and C7, right? Look at it. Tails underscore IDX on C6, tails underscore IDX on C7. So I'm using one single index, right, on two tables. This is what we call a composite index. Right? Composite index. One index, you're using one index on multiple tables, right? It's called a composite what? A composite index, right? So you can also drop index, when you are done with the index, right? Composite index, right? This is what a composite index is. You're adding multiple indexes, or you're adding a single index on multiple tables. That's basically what we call multiple composite index. Look at it. Indexing here. I'm indexing column 1, column 2, column 3. And I'm using what's just one index underscore name, right? So that is what we call composite index, right? Composite index. So you'll be doing that on your next assignment, right? We'll be adding index on tables. We're adding index on columns on tables, right? So we've seen how to create index. What index are? Primary key constraints are created when you create a primary key constraint. A primary index is created for that column. When you create a unique constraint, a unique index is also created on that column, right? If you describe, look at it. Let's even confirm that. If you describe driver's license, let's see the index on that table, right? Look at it. We have a primary key constraint on this table. Can you see key index primary? Phone number, can you see it's saying that what you have a unique index on it? Can you see unique index, right? You can create a unique index by just specifying that you want a unique index, right? Create unique index, can you see? Create index or create unique index on the name of the table you want to. So basically, you can add index to your table. Let's create a unique index on, let's see. What column can we add index to here? Are you following me? Please let me know if you are following me. Let me know if you are following me. Let's check the citizens table. Okay, awesome. Let's use the citizens table. Let's describe the citizens table. We don't have index on it. Please let me know if you are following. Right, so this is our citizens table. Hold on. Where is our NIN? We didn't add NIN. Okay. All right. Local government, blah, blah, blah. All right. Create. Madam Susan, talk to me.
No, sir, because we should raise our hand if we are following. That's why I raised my hand.
Can you hear me?
Yes, sir.
Okay. You wanted to ask me a question?
No, I said when you asked if we were following you, that's why I raised my
Okay.
hand.
Okay. Thank you. Thank you. Thank you. On the citizen table, right? So I want to create an index on the primary key and citizens table. So I want to first of all I want to alter the NIN, add primary key to constraints. I want to citizen modify. Primary key. Are you following me? So I'm adding to add a primary key index, to add the primary key constraint on the citizen NIN table, on the NIN column of the citizen table. I altered the citizens table and I modified that column. Knowing that if I had a primary key to it, what happened? Primary index is added to it. Can you hear me? I hope
So I think
Yes,
it's
sir.
breaking.
Sorry, it's breaking, sir.
so. Let me know if you are following me. Just raise your hand if you are following me. I want to know those who are following me. We're too quiet.
So I'm following you, but it was breaking for a while.
Yes, I was breaking for a while. We are following you.
I'm the only one that can't hear anything.
No, I think his network is bad.
Oh, okay.
Can you hear me?
Yes.
Oh, sorry. The evil agents that they sent started again. So it cannot work. I'm good now. Let's continue. Ebube, talk to me.
No, sir. Sir, it's from the time you said we should raise our hand if we were following
Okay.
you.
All right. Good people. Right. So here, what we are doing is look at it. I hope you can see my screen now. I hope you can see my screen. I hope you can hear me.
Yes,
Just follow me.
I can hear you.
Awesome. Just follow me as I follow Christ. All right. So yeah, what we are trying to do is I wanted to create a primary index and a unique index on the citizens table. And the first thing I want to do is to add a primary key constraint to the NIN column, right? And I know that if I create a primary key constraint on the NIN column, what happens? It is going to automatically create a primary index on that column for me. So that is what I'm doing here. So if I run that, right, that is right. I'm going to create index, and I'm going to call that index citizen underscore IDX, right? And I'm going to say on what? On citizen table, right? But what column of the citizens table do I want to add this index to, right? Let's say let's just pick some columns at random. I'm going to say last name, and residence underscore address. Right, good. Are you following? So I'm creating this index citizen underscore IDX on the citizens table, and I'm adding it to 3 columns at the same time. Of course, we know that that is what? That is a composite index, right? So if I run that, we'll see all of that much later. Lastly, we want to create a unique index. Create unique index. Let's call that citizen underscore phone number underscore unique index, right? On citizens table, which column am I adding that to? Phone number. I'm creating a unique constraint on the phone number column of a unique, I'm creating a unique index on the phone number column of the citizens table. If I run that, what do you have, right? So let us describe the citizens table now and see all the indexes that we have added, right? So that run this, right? Can you see primary key, right? Unique key, right? Can you see, right? So you can see that if I say show index from citizen, right? It would show me all the indexes that is on that table, right? Look at all of them, right? Primary key on NIN, citizen that we created, citizen underscore phone number underscore unique index on phone number. Can you see? Also a B tree. Then the composite that we created, last name, residence address, and state of origin. Right? So we'll be doing this we'll be adding this to assignment. So the next assignment that we're going to be doing, we're going to be creating a table. We're going to be look at the first assignment we did was to create a table. The second assignment we did was to create a table and add constraints. But this time around, we're creating a table, we're adding constraints, we're altering the table, we're adding indexes to it and all of that so that our knowledge can be full. Right? Please raise your hands if you understood all of this before we move to DML. Please raise your hands if you understood this before we move to DML, right? Before we move to if you have questions as well, please do ask your questions now before we proceed.
Please, can you leave the teams so that I can see what I wanted to ask? Please, what does this B3 mean?
Sir?
What does B3 mean?
B3 is there are two types of index actually. I didn't want to go deep into it, right? You didn't see, I drew a B3 index. The diagram I drew here, yeah, something like this. Can you see my screen? Oh, yes. It's gone, right? Yeah, the diagram I drew on this part, right? That's the B3 index. We call it an hierarchical index, right? When you have that kind of hierarchy, that hierarchical diagram, that's a B3 index. Then the second type of index is a bitmap index, right? Bitmap index is not a common type of index, but in bitmap index, you use hash numbers and colors, right, to tag individual values, right? I don't want to go into that. It's more complex and all that. It's for basically database administrators, right? We don't want to go into all of that. But there are two types of indexes. We have B3 indexes and bitmap indexes. So B3 indexes uses a tree-like hierarchical tree form kind of index, right? That's what it does. Yeah.
The index in our
Any other question?
What did you catch when you told us how to search for something?
How to do what?
Search for something with the index that we're doing.
How to search for something?
Yes, like if we're looking for something on the table.
Now, the index works automatically after we have added it, right? What it means is that on any column that you want to take, for example, if I'm looking for a particular NIN, because all those NINs are now unique because I have a primary key index on them now, a primary index on them, right? The index is not for you to use. You have created it on the column, but it's not for you to use. It is for the server, the database server to use. Do you understand? It's like an oil in the engine of the server that makes it return query faster, right? So it is not for you to use. You just create it either implicitly or explicitly. Implicitly means you are creating it, the system is creating it by itself using the primary key constraint or the unique key constraint, right? When you create it by yourself, you call it an explicit creation of index, right? When you create that, either way it is created, that is all that you can do. That is all that you can do. When you want to retrieve values from that column, from the table, as long as you're using those columns that you have indexes on, the query performance will be improved because of the function of that index. Do you understand?
Yes.
Yeah, so you're not the one using it. We'll talk about writing queries very soon. We'll talk about writing queries. Okay. That's what we've not started talking about writing queries. We'll talk about writing queries much more later. Very soon we'll talk about writing queries.
Sorry, sir, can you close this results table? I just want to see the code you wrote up.
Any other question?
Yes, sir. Sir, can you close this results table? I want to see the codes you wrote up.
Can you see it?
Yes, I can see it.
I'm waiting for more questions. All right. Data manipulation language.
Sorry, sir.
That's the
I
next.
tried this.
Yes.
Sorry, sir. I tried this alter table citizen, like modify NIN stuff, and it told me I have multiple primary keys defined. What does that mean?
It means that there's a primary key on it already.
Okay, so I can't do this when I already have a primary key that's already created.
If you have a primary key on a column already, you cannot add a primary key on it anymore because the primary key is on it and it also has a primary key index already. So you have to index other columns. But for that column is set.
Okay. Thank you.
Any other question before we move to data manipulation language? Any other question before we move to data manipulation language? All right. So we're moving to the next part of SQL. We've talked about the DDL statement. Basically, we've covered it all. Create statement, alter statement, rename, drop, and basically, yeah, that's the 5 of them, right? Create, alter, drop, rename, and which other one, right? We've talked about all that we need to talk about. We have one left, but we'll talk about it at the end, which is truncate. Truncate basically is to delete every content in the table, but we don't have a table we don't have a table that has data to be able to practice that. That's why I'm not talking about it yet, right? But we want to now look at how to. So we've created these tables. We've created these tables now, right? How do we fill up these tables with data, right? So we have created tables. We've learned how to create tables. We've learned how to adjust the structure of a table using the alter table statement and all of its components, right? We've learned how to add constraints to sustain domains and data concurrency and data accuracy and data consistency, right? We've also learned how to improve the performance of queries using indexes and indexing, right? So what do we do next, right? Now that we have the table and the structure of the table is good, we built the house. The house is beautiful now. We need to pack in. We need to move in. We need to bring all our stuff in, our TV, our chairs, our beds, our mattresses, our kitchen equipment, all of the gym equipment, everything that needs to be in the house, the accessories, everything needs to come into the house now. And that's what we do with data manipulation. With data manipulation, we populate the table and with what? With data, right? We're able to fill the table with data. We're able to fill the table with data. And of course, in filling the table with data, we also need to be able to update the table when there are changes in the data and also deleting content of the table when they are no longer needed, right? So when we talk about DML statement basically consists of what? It consists of 3 clauses, right? We have this insert, we have the update, and we have the delete statement, right? Insert, update, delete, right? Insert, update, delete. This part is very, very essential for you as a data analyst because you are going to be creating data. You're going to be working with data. Hence, you're going to be inserting data sometimes. You're going to be updating data sometimes. You're going to be deleting data in some other cases. So this is very important for us to understand, right? It's very important for us to understand. So DML statements basically helps us populate the table, or basically we use them to what? To work with the content of the table. To manipulate content. of a table. Right? So let us take, for example, let us look at, let's start with a simple table. Do we have any simple table here that we can use that does not have too much of data? Let's go to MTN. Let's see departments. How many columns? All right, let's use the MTN database or schema, right? So that we start gradually. Use MTN. Inside of MTN, we have a table called the departments table. So we describe that table. Right, let's describe that table. If you're following me, please follow me back to back. Right, so this table has 3 columns. So let us, now, when you want to query a table, I will just talk about querying briefly, right? We'll talk about querying later. Querying a table. I want to see the content of the table. Querying a table is how we fetch data from the table. How we fetch data from the table, right? By the way, we'll talk about the concept of foreign key later. For those who do not understand foreign key, I'll talk about foreign key later. Please remind me that we've talked. I want to go over foreign keys again, right? I just remember that somebody mentioned that they didn't understand foreign key, so I'll go over it again. Please just remind me. But let us continue, right? So creating a table is how we fetch data from the table. So we have this table called departments table. I want to fetch data from the table, although there is no data on the table, but I just want to show you what we do, right? So if I say select, we use the select statement to do that. If I say select all, right, from departments, don't worry about it. You understand what all of this means much later, right? Select all from departments, right? If I run that, what happens? It gives me the headings of the table, like in Excel, and there's nothing inside of them. So there's nothing inside of this table. How do we now populate what? How do we populate this table? How do we populate this table with what? With data, right? So we use what? The insert statement. So we want to talk about insert statement, right? And we're going to do that. So insert is how we insert into the table. So I'm going to say insert into. I told you that SQL is English language, right? So insert into, what's the name of table? We're inserting into department. That's basically the statement. Insert into department, right? Then what do you want to insert? Values, right? We'll say values. Then you open your bracket. Now, when you are inserting the values, each of the column must what? Must carry a value, right? So in this table now, we have 3 columns, right? We have 3 columns. And these columns are, look at it. You must understand the description. You must understand the description of the table so that what you are, so that you can insert the right thing inside the table, right? The description of the table is here. Look at it. We have the department ID, which is integer. We have the department name, which is virtual, and it has a length of 30. And we have a what? A location, which is also what? Which is also integer, right? So if I'm going to insert into this table, right, I'm going to insert, what's the first thing that this table is requires for me? This table requires for me the department ID. So I'm going to say department ID is 10, right? Department ID of 10. Hold on. I want to use, okay, yeah, I want to make it neat, right? That's why I'm looking at that. All right, so department ID of 10. Let me reduce this. Hold on. Let's run this. All right. Department ID is 10, right? Department name is admin. Let's start with admin. Text has to be in quotation mark, right? Admin, let's call it admin. Don't let us stress it. Admin. And locations is locations, let's say locations 1,200, right? That is our value, right? So if I say insert into department, then these values. Remember there are 3 columns and I provided the values. Let us run it. Let's see the magic that it does. Right, look at the result. It says insert into blah, 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 blah. 1 row affected, right? Now, let's confirm if that insert has worked. So I'm going to query the table by saying select all. These asterisk here means all. Asterisk means all. Aha. So that asterisk, we call it is a wildcard. It means all. It means all. So I'm saying select everything from the table. Now, this table, when you say all means that remember that your table must have a dimension, rows and columns. When you say select all basically means return all the rows and all the columns. Are you following me? It means return all the rows and all the columns. We'll talk about that when we get to querying the database using select statements. That is a full topic that will last us over a weekend, even on, yeah, about maybe 1 or 2 weekends, right, for us to finish that. So we might have to extend the SQL class a little bit, right? So we have inserted into this table department. So we want to check what is inside now. So if I run that, can you see department ID, department name, and locations, right? So what I want you to do, everybody, right, launch your MySQL and insert into, do you have the department table? Do you have the department table? If you do, right, if you do, insert into it. Let's try it. Let's try it. Let's try it. Let's try it. Let's try
I don't
it.
have the.
You don't have it.
So we have to create the department table before we now launch inserts into it.
Yeah, so if you can create the department table, just create this table. Good, perfect. Thank you, everybody. Right, everybody create this table. Right, it's just a simple table, a 3-column table. Right, create it inside any of your schema. Right, create the table and insert into it. I give us 5 minutes to do that. 5 minutes. Are we true? Are we true? Should be done by now. Things are not hard. Are we true? Are we true? Queen, are you true? Madam Oduak, are you true? Where's Madam Peju? Saw her before. Oh, she's not in class. Madam Olaide, are you true?
I'm through.
Awesome. Did you work?
Yes, it did.
Awesome. Awesome. You're writing statements already.
No, sure.
Kudos, 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 kudos. Waiting for others. Queen, are you there? Solomon, Madam Susan. Okay. Madam Alakoju, you are here. Talk to me. Madam Olaide, talk to me. Madam Angela, a personal person. Yeah.
I'm done.
Oh, yo. Talk to me, everyone. Talk to me. Biola, Ebuka, Femi. Madam, I know you are very quiet today. What's happening?
I'm
Talk
working
to
on
me,
my own,
everyone.
sir.
Talk to me. All right. We're almost time. I will say pens up very soon. Pens up.
I'm done.
Awesome. Who's done?
Yeah,
That's
after
Madam
create,
Koyu. Yes, talk to
Yeah.
me. Awesome. Yola, talk to me. Queen, talk to me. Follow me. Talk to me. Give Jesus a big hand. He was blind. He has set the course that I must follow. Prosperity. Talk to me, people. Don't mind me. Putting. Hello. Ebuka. Femi. You are not done yet.
So I'm good. I'm done.
Awesome. Femi.
so I'm not done. No, I am stuck. I've created the table for department. Then
Okay.
after I write the insert function, I don't know the
So,
next
who is
thing.
this? Who is this?
It will be.
And now, so after you have created this, you've run this, Abi?
No, sir. I've created just the department.
And after you created the department table, insert into it, right? Use this statement that I have selected, use it to insert into it. Then once that is done, you now run select all from employment from departments to check the content of your table. Does that make sense? Does that make sense? Are we good?
Almost done, sir. Can you remove this
Please, can you go over it again?
team?
Biola, what did you say? But I give you blue. Sorry, I should put that part.
I was kicked out of the class.
It's hard to what value.
Biola, what did you say?
You were saying, do we understand something? And I asked that I should please go over it again.
Why? Where have you been? Why? Why should I go over it again? Where have you been?
I was here until you asked us to do this insert in department table.
Have you done your inserts? Have you
Yes.
created the table? Do you have the department table now?
Yes.
Have you inserted into it?
Mm-hmm.
Yeah?
Yes, sir.
So after you've inserted it, then you run this select all from. Let me remove this asterisk. Maybe that asterisk is what is causing the quarrel, right? Let me push this.
Sir,
Select all from department.
Okay.
Yeah.
Sir?
Talk to me, madam. Yes.
I am here. So I created I write the create table.
Okay.
Department.
Okay.
So I highlighted it. Then I run it. I don't see anything.
You didn't see it.
Hey, I didn't see it too.
Why? What happened? Snap what you have on Telegram to me. Snap what you have and send it to me on Telegram. Let me see.
Oh, okay, sir.
All right. I want to believe every other person is good so that we can move on. We can move on. All right. So let us insert another value, right? So we say insert into departments, right? Insert into department. We say values now. Right? Values, you open your brackets, 20 IT 1,200. If I run that now, I go back to run my select all from departments. What do I have? Can you see? I have 2 departments now, or 2 data, 2 observations, 2 rows in my data now.
Hello, sir.
Right? Does that make sense?
Yes.
Can you see that the table is growing already? The table is growing already.
Hello, Mr. Shem. Hello, sir.
Talk to me, I can hear you.
Okay, sir. Do we have to do all this research every time we want to do it?
I can hardly hear you.
Okay. Do we have to do insert into departments each time we want to insert into this same table? Is it not possible for us to just keep typing?
Okay.
Since we've already put insert. Can you hear me, sir? Hello, sir. Oh God, have mercy. Mr. Sheung,
Hello.
can you hear me now?
Yes.
You can hear me now, sir. I'm shouting, though. Hello, sir.
I can hear you now.
Okay. I said, do we have to do it, put insert?
I can hear you now.
Do we have to put insert into all the time, every time we want to put something in the table?
Yes, you have to do insert every time you want to put something in the table. Yes.
Okay.
Eh? Yeah, come on, then. Eh?
Any other question? Any other question? Please mute your mic for me, please. Please mute your mic for me. Any other question? Right. So that is insert, right? We'll talk more about it. Right. Let's talk about the next one, which is to update. Right. I hope you can hear me. Update statement. Right. We want to talk about update statement. Right. We want to talk about update statement. I hope you can hear me. Update statement. I hope you can hear me and you can see my screen. So what if I want to change the name of the admin department to administration? Are you following me? Are you following me, please? Let me know if you are following me.
Hello, sir. I think it's cracking though.
Hello, can you hear me? Hello, are we there?
Yes, sir, we can hear you. Yes, sir, we can hear you.
You are not responding. If you don't respond, I won't know, right? Please respond so that I can move. You can move. All right.
So I've sent it on your this thing. On your Telegram, sir.
Oh, your create department is not complete now. Check the code and try. Your create department is not complete. That's not how to create department, right? Yes. Check your create department statement is not complete. Go back to the codes that we've run earlier to check on create department statement, right? Your create department statement is not complete.
Okay, you are talking to me, sir.
Do you understand me?
Are you talking to me, sir?
Yes.
Okay. I should go back.
Yes, I am.
What do I supposed to do then?
Yes, go back to your create department statement is not complete.
Okay.
Yeah. Let me see if I can create department. I have that code here instead of rewriting it. All right, look at it. You didn't do this. You only said create department. You didn't specify your department name, your department ID, and your location ID.
Okay.
Yeah. So all of that is missing.
Okay,
Check the code. You have the code. Check the code.
Okay.
All right.
Let me do that now.
All right. Now that we have inserted into a table, right? Let's do some more inserts so that we can have more values to use. Let's do some more inserts. Copy. All right, let's do some more inserts. Right. I want to try something now. Remember that we created Department 20, IT, and 2000 before, right? Let's run it again to see if it will allow it enter. Right. Look at it. Hello, everybody. I want you to pay attention to this. Look at this, right? I created Department 20 before, right? I've created this before, and I ran it again. Let's select from that table to see what happened. Let's see what we have. Look at it. We have two Department 20 now. We have two Department 20. Who can tell me why? Why did this happen? Why did it allow this? Who can tell me?
I think you did not specify any primary key.
Exactly.
There was no constraint.
There is no constraint on the table. Do you understand? There is no constraint on the table. Hence, it can allow for duplication. There is no constraint on the table. Are you following me? There is no constraint on the table. That is why you have that. Please, 1 minute. NEPA has brought light. Let me change to NEPA. Thank you. Are we good? So that happened because why? There is no what? There is no primary constraint on that table. Hence, duplication is allowed, right? Duplication is allowed. That's why, right? So let's change this to 30. Let's change this to 6. Let's change this to 1,300. Let's run this. Let's change this to 40. Let's just change this to human resource. Let's change it to 1,003. Let's change this to 50. Let's change this to marketing. Let's give this 1,004. Right, so if I say select all from departments, what happens? Now we have multiple values in that situation, right? But look at it. We have 220, Department 20, which is IT, and 1,200, right? That's an error, right? I want to change one of them to Department 60, right? And what was that? Procurement department. How do I do that? Right? I would say that we use the update statement to do that. Update department. Update department. Right? Set depth ID equals 60, where depth ID. Now this is tricky, right? Because it will change for both of them, right? So Let's see what we can do. Is the two values are the same? All right. First of all, we have to delete one of them. Let's delete. Hold on. That's, you see the challenge with not having a primary key on the table. Because if look at it, let me even run it, right? What am I doing? Let's update it. Let's update department so that you can see what that can cost you, right? Update department, set debt ID equals 60, where I'll explain all of this later to you, right? Where debt name equals IT, right? If I run this now, sorry, I'm coming. It's preventing me from doing that. I need to change something. Preference. Query editor. Coming. Safe mode. 1 minute, please. So it's now 1 minute. Enable code completion, beautifier, institution. 1 minute, please. Let me find out. Okay. All right. So I should be able to run my code now. Hold on 1 minute. Hey. Okay. Sorry. First of all, let's save this. I'm trying to remove why it is not allowing me to run that code. All right. Okay. It has worked. I need to have reconnected it. Hello, can you hear me? Please. Are you following me? Please let me know if you are following me.
Yes.
Yes.
Awesome. Right. MySQL, your MySQL presently is in safe mode, right? Safe mode will not allow you to do updates if you look. I want to show. I want to read this. It says error code 1175. You are using safe mode and you tried to update a table without a where clause that uses a key column. Disable plenty story, right? Basically, what it's telling me is that I am in safe mode and I cannot perform all the update statements. So to remove your system from safe mode, I mean your environment from safe mode, you go to edit, you go to preference, and preference will give you this dialog box. And in your editor, your SQL editor, click on the SQL editor, you come down and you deselect the safe update. Can you see safe update? You deselect it, then you say okay. But when you do that, right, it will not take effect until when you reconnect the database, right? So you have to reconnect the database for you to continue, which is why I reconnected here, right? That's why I reconnected here. Can you see? So I'm going to continue from here, but I'm going to update that statement and send it to you, right? So I'm going to continue from here. So if you look at it, after doing that, I was able to run my statement. So let us select, I just updated. Update means that I'm changing values from my table, right? So select all from department. Let's see what happens to that update, right? Look at it. Can you see that both of them are now what? 60, right? Both of them are now what? 60. Even though there was what? There is a where clause in it, right? Now, let me explain what this statement does to you. So this statement basically is saying that update department, right? Set department ID to what? To 60. For now, the where clause is a restriction column, is a restriction function or a restriction clause that helps me limit what I want to update. If I remove this where clause, right? If I remove this where clause and I run just this statement, what it will do is that it's going to set all the department ID to 60. All of them will be 60. And that will be an error. Are you following me? That will be an error. So we use the where clause to target a particular what? A particular row. So I'm saying that where department ID is what? Is a department name is IT. So isolate that particular row and do the edit on what? On the department ID. But because the two columns there share the same name, right? You can see that he edited both of them. So to fix this error, I have to delete both of them. So delete.
Hello, sir.
From, yes, talk to me.
Can we put where the first department name is equal to IT? Is it possible? Since we have two.
Can you put what?
Is it possible to put where the first department name?
No.
Okay.
No. The fact that I say SQL is English doesn't mean you cannot be writing your own English, yo. SQL is English language. Does not Does not mean you now begin to write your own English. Oh, eh? Madam, you are writing English. Okay? All right. So we'll drop from departments where now, if I want to delete from department, if I don't put a where clause, right, what happens? It's going to delete everything. And I don't want it to delete everything. So we use the where clause, right? We use the where clause. I say where department depth ID equals 20. So delete from department where department ID equals 20. If I run this now, right, let's select all from department again. You'll see that department, right? Hey, it is department 20 that I removed though. Sorry, department 60. Sorry. Department 60. Right? Let's select all from. You see that department 60 is gone. Both of them are gone, right? Both of them are gone. So let's bring back department 20. We had the department 20 before. Let's bring it back. IT. So I'm going to copy this, copy. I'm going to come to my script here. And I'm going to paste this. And I'm going to rerun this. And my department 20 will come back. So if I select all again from department, what happens? My department 20 is back. Can you see? Department 20 is back. Can you see 10, 20, 30, 40, 50? Right? So that is how we insert and update. So now if I want to update, right? Let me update now. Update. Let's update properly now. Right? I want to change update statement. Change the IT department name to data analysis. Right? So how do I do that? I say update. What's the name of the table? Departments. Right? Set. What am I setting? Department name, Abby. What's department name? Set depth name. Can you see? It has to be the name of the column. Set depth name equals what? Equals data analysis. Right? Now, if I do this, if I run it this way, it will change every department name to data analysis. Right? It will change every department name to data analysis. So I just want you to change for a particular what? For a particular department. So I'm going to say where what? Where department, where depth ID. I'm now going to use the lookup value. The lookup value for that column is what? Is 20. That's the lookup column is what? Is department ID. Right? So I'm going to say 20. Right? Where department ID equals what? 20. If I run it now, right? It says that it's what? It is successful. So let us select and see what we have done to see if it is what? If it is good. So we select all from department now, right? Department 20 is now data analysis. Department 20 is now data analysis, right? Let's do another update, right? Just to get it right, just to get it, to understand it. Let's change location, right? Change, update the location of the department sales to 1,500. We're changing them to a new location. All right. So we have a new location that is 1,500. So we're changing them from their present location to location 1,500. So how do we do that? Right? We say update department. Set, what are we setting now? Location, right? Locations column equals to what? 1,500. What am I supposed to put now? Who can tell me?
Where location
Where what?
um when debt ID is
Where department ID?
Department ID.
Okay, where debt ID equals what?
what's the number for location?
Equals 30.
Where debt ID what?
Equals
Equals
30.
30. Thank you. Equals 30. You are changing for the sales department. The sales department is 1,300 before, but now we are changing it to what? To 1,500. So it is the debt ID for that department that you're going to use, right? So we run this, right? If we select from departments, select all again. Let's query the table. We should have sales in what? 1,500, right? Can you see sales is now what? 1,500. Does it make sense?
Yes, yes, it does.
Do we understand it now?
Yes,
You know,
sir.
all right. So while finishing DML, this is all about DML, right? We want to finish DML today. This is all about DML. How do we? So somebody asked me a question earlier, and I said, yes, that's how we do it, right? But I just said that so that we can, I don't want to jump the steps, right? How do we insert multiple values at the same time, right? How do we insert? I know that people like, right? So how do you insert? Let's assume that you want to insert, say insert 5 new departments into the department table, right? We have 5 new departments, and these departments are department finance, audit, personnel. Which other department is there? Somebody help me. Product
Logistics and
management.
transport.
Product team. Logistics. Thank you. Right. Procurement. All right. So we have all these departments that we want to insert. How many is this now? 1, 2, 3, 4, 5, 6. So let's say we want to insert 6 new departments, right? How do we insert them, right? Do we have to do 6 different insert statements, or we can insert them in a single statement, right? Let's say insert into departments, right? Values. Right? So department 7, let's give we have department 60 already, so let's give 70 to finance. Let's put them in location 1,500, the new department that we created, right? Comma, when I enter, right? Department 80, what department is that? Audit. Let's put audit in department 3 or 1,300. Put a comma again. Let's put what's the next department? Personnel in department 90. Let's call them department 90. Personnel. Let's put them in 1,200. What's the next department? Let's call them department 100. That's product team. Let's put them in department 5, 1005. Let's close that as well. What's the next department now? Department 110. Right? Logistics. One three. And lastly, procurement 120. Procurement 1,400. Right? So if I run that, each of these brackets are closed. If I close my, right? Let's run that. Can you see? All of them inserted at the same time. Oh, wow. Let me bring all of these down. Can you see? All of them inserted at the same time. So let's check to see that what we did was good. Select all from. Now I can write my select all from the department on the same line. Let me show you that. Right? But we usually separate the clauses for readability, right? For good code ethics and readability. So select all from department. Can you see all the departments we added at once? Right? So from department 50, 70, okay, we missed 60, 70, 80, 90 to 120. So these are the departments that we just added. Can you see? So that is how to do a multi-value insert, right? You can insert multiple values at the same time. Multiple values at the same time. I think it's Madam Anu that asked me that question. Are you satisfied now? Are you satisfied now?
Yes, sir, yes.
Life is easy now, ba.
Yes, sir.
Done. All right. Right? So, Ebube, talk to me. I see your hand raised.
Yes, sir. Yes, sir. I want to
Talk to
get when and where do we use the drop and delete statement? Because there was a place you use delete to delete something, and then you earlier said you use drop to like remove a table. So when do we use the different?
Thank you. Thank you.
Hello, sir. I can't hear you. Is it just me or it's cracking for everyone?
I can't hear him at all.
Can you hear me now?
Yes, sir. I can hear you now.
Yes. Drop is a DDL statement, right? Drop is a DDL statement, which means that we use it for anything that has to do with the structure of the table. If I want to delete a column here, right, I use drop. If I want to delete the locations column, what I'm going to use is what? Is drop, right? Let's try it. So I say drop alter table, sorry. alter table department, right? Drop location. Right? The location column is gone. If we run this now, you see that the table now has two columns instead of the 3 that he had before. So we use the drop statement to delete structure. You can delete the table, you can delete the column. Anything that has to do with the structure of your table or an object on the database. We use it to delete objects, right? We use it to delete objects. But delete is used to delete the content of the table. Delete is used to what? To delete the content of a table, not to the structure of a table. The content of a table. That's what we use delete for.
Okay, sir. Thank you,
Does it
sir.
make sense now?
Yes, sir.
All right. Any other question? Any other question? Any other question?
Yes.
Talk to me. I'm waiting. I'm waiting. Any other question? Any other question? Right? So the same way you did multi-value insert, you can delete multiple values at the same time. Right? You can delete multiple values at the same time. You can update multiple values. Can we update multiple values at the same time? Think about it. Updating multiple values at the same time. No. We can only insert multiple values at the same time and delete multiple values at the same time. I'm not sure we can. I'll check it. I'll check it. I'll check it. I'm not sure we can update multiple values at the same time. I've not tried it before. But we should be able to do it. Set. Let's try it. Right? Let's try it. Updates. Set. What do we have there now? Set depth ID equals 150, where depth name equals finance. Nope, you can only do one update at the same time. Are you following me? You can only do one update at the same time. You can only do one update at the same time. Are you following me? But you can do multiple inserts and multiple deletes. So I think it's only multiple insert you can do. I think it's only multiple insert you can do. You have to delete one after the other, and you have to update one after the other. Yeah. You have to delete one after the other. You have to update one after the other. Any other question? Right. So, what have we done today? Today we started with check constraints. Of them, revision on check constraints. Right. We started with revision on check constraints. Hold on. All right. Yes, we started with revision on check constraints. Then we talked about indexes. We said that indexes are objects that helps improve query performance. We talked about the fact that whenever you create a primary constraint, a primary index is created. Whenever you create a unique key constraint, a unique index is created. And we also looked at how to create indexes and attach them to tables, and how to create a composite index. The composite index is using one single index on multiple columns, right? That's composite index. And we also talk about using the show index from the table name to see the number of index on a particular table. We also went ahead to create multiple indexes. Then from there, we started talking about the insert, the update, and the delete statement, right? Which is the data manipulation statement. And we said they are used to what? To manipulate the content of a table, used to manipulate the content of a table, right? Then we talked about the fact that we've created a table before called the departments table, and we queried the table to see that the table was empty, and we started populating the table using the insert statement, right? And we inserted into the table using the insert into department, then value. So basically, what this means is that if you have like this table here we have here, which is going to be where our assignment is coming from, how many columns do we have in it? Right? Employees table. How many? 1, 2, 3, 4, 5, 6, 7, 8. Right? Or we'll look for, I think, yes, citizen table. I think that's a more structured table. Citizens table. Right? It has all the necessary constraints. Awesome. Right? So we'll probably be using the citizens table or the driver's license table for our, for our assignment, right? So, but basically what that means is that you have to be able to add, if, say for example, look at this table now. How many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 columns, which means that you have to give 10 values for, each of the columns. I mean, you have to give all the columns, all the 10 columns, each value, right? Each of the columns must have a value for every observation, right? So here we're using a column that has just 3 columns, right? So we have 3 values that we're inserting. We insert values for the department ID, department name, and the location ID. In this situation, you insert NIN, location, first name, last name, and so on and so forth, right? So we inserted into all of those tables, into the department table, one after the other. And we also used the update statement to change values, right? And we said the update statement is used to edit. Same way we use the alter statement to edit the structure of a table, we use the update table statement to edit the content of a table, right? So the table the data already exists, but we're using the update statement to change its value, right? To change its value. So use the update, the set, and the where clause. Now, this part is very important. The where clause is very important because it's what helps you restrict the update to a particular row and not the entire table. Now, what happens, right? I don't want to talk about it, but let me talk about it. What happens when you do a mistake and you mistakenly deleted the old table, or you mistakenly updated the old table with a single value, right? Now, we have not gotten there, but all these changes that we have made, they are not permanent yet. They are still in memory until when we save them. Remember that we said that what DDL statements are auto-committed statements. They are auto-committed, which is that they save automatically. But DML statements are not auto-committed. You have to save them. So you have to commit the statement. I will explain that better in our next class. I'll explain that better in our next class. So basically, everything that we are doing presently is still not saved yet until when we save it, right? But what happens if I mistakenly deleted or updated all the department IDs to 60, right? Without choosing a where clause, and I committed it, I saved it, right? That is a big trouble for both you and the database administrator, right? The database administrator would have to delete that table and recover it from a backup, right? Although in databases like Oracle, they have several technologies to rewind the database to a particular point in time using flashback technology, using black house, and so on and so forth. They have several technologies that they can use to rewind the database, right? Where such that the database is online and is also being rewound, right? I don't want to go into that, right? But Oracle has all of that, and that's one of the reasons why it's the best database system or DBMS in the whole world. There's a whole lot that they can do that most DBMS cannot do, right? So, but what it means is that when you're using DML statements, right, my emphasis will be that you have to be careful. You have to be very careful to know what you are doing and be consistent with what you are doing. And that is why the constraints are very important. If you put a constraint on the table, it will put your values in check. Look at the earlier today while we were in class, I was using department table and the department table did not have constraint on it, and it allowed multiple values, which was an error, right? So, and if you look at it, when we wanted to update that table, right, we could not update it properly because why? It was updating the two records at the same time. So we had to delete them and recreate them. So we use the update statement to update, and of course, we use the delete statement here to delete content from a table. Right? So we use the delete to delete a row. So basically, that is what you have in DML statements. DML statements are no more than that, right? I told you that they are very small. We can easily cover them in a single class. So today we've talked about DML statement, which contains the insert, the update, and the delete. Any question before we wrap up today? Any question? Any question? I hope today has been a beautiful class. I hope we enjoyed today's class. I hope we learned something in today's class, right? Your assignment is coming big, right? We have covered a lot, and I want to tie everything that we have done into the next assignment. So because we have to continue to build and continue to do like that. So everything that we have done from the beginning of the class to this present moment is going to reflect in the assignment. It's going to reflect in the assignment. So please and please, the videos are going to be available. The last video has been uploaded already. Today's video will also be uploaded today or tomorrow so that you can have access to it during the week. Please go through it and learn more. If you have questions, drop them on the group or message them to me. I would reply your messages, right? We continue to learn. Presently, at the moment, right, you're an SQL developer, right? Because you can create, you can update, you can create, you can alter, you can drop, you can use DML statements. You are good to go. What you have left is just to be able to write queries on your tables, and you are good to go. So we have about 2 or 3 classes left for SQL before we move to Power BI, right? And that's where we're going to be discussing the select statement. We'll talk about select statement in full. It's a large statement, or it's a statement that has a whole lot of content or a lot of things to cover. So it might take us more than one. In fact, it's going to take us more than 2 classes. And this is our 3rd week, right? This is our 3rd week. So we'll look at how we can do next week, right? If we can cover it next week, fine. If we cannot, we'll extend it a little bit, right? Because it's very, very important. It's actually the most important part of the SQL for us as data analysts. That's why I pushed it to the end so that we can understand it better. Then from there, once we're done with that, right, we'll start with Power BI. Any question before we wrap it up today? Any question? Please indicate to me, just raise your hand if you enjoyed today's class, right? I know that there was a bit of here and there in between network and all of that. I had to switch between network today so that, remember I told you that I was going to switch between network. I was going to make sure that what happened yesterday did not happen today, right? So please just raise your hand if you really enjoyed today's class. I want us to learn, right? I want us to really learn. Thank you, thank you, thank you. I'm really appreciative that you're giving your mind to this class and you are and you are keeping up with me, right? Thank you so much. If you have not submitted any assignment, I am watching you. I will catch you. If I catch you, oh.
Hello, sir. Check your this thing.
All right, I'll check after class.
Okay.
All right, I'll check after class. Right, I'm seeing people that have not submitted one assignment. Femi, I will call your name. Moyo, I will call your name. You have not so Queen. If I catch you, oh, I will tell you.
Sir, I'm very sorry, sir. I'm having problem with my network and everything. Even in the last class and this present class. In fact, I just came. I've not been following, but I'll watch the videos and I'll
watch
come
video and do
see
assignment. All those ones you are talking is an excuse. I will not put you in the same grade as.
Yes, I'm going
understand?
to do it. I'll be fine.
All right. All right. Any question? Any question before I stop recording? Okay. If there are no questions, I'm going to stop recording now so that we can go back to our